Is it visible? Is it visible?
Yes, sir.
Yes, sir.
Okay, so let me start. So yesterday we started with the shortcut method. Three methods are there to find the particular integral. So shortcut method. One is general method. Already we studied general method. Now we want to study second method, shortcut method. Then in the shortcut method, we are studying shortcut method for the exponential function e raised to x, and we obtain this formula 1 upon phi of d. This is operator operated on e raised to x, that is equal to 1 upon phi of a e raised to x. So in short, we replace d by a. That's it. Okay, so we'll go through few examples. Start examples. Write this formula and remember the punchline. What is it? We have to replace d by a. Okay, so find. Better write in this way. Question. Find pi for following differential equations. So our aim is to find a particular integral only. Yeah? We know how to find the complementary function. So we are not concentrating on that. So d square plus 9y equal to e raised to minus 2x. So y of p equal to 1 upon d square plus 9 e raised to minus 2x. What is to be done? Replace d by minus 2, coefficient of x. So 1 upon minus 2 square plus 9 e raised to minus 2x. So 4 and then it is 13. That's it. This is the answer. No need to integrate anywhere. Okay. No need to use the 1 upon d plus m or d minus m formula. And you might have observed that if you try to find, let me write it here. If you try to find roots of this d square plus 9 equal to 0, the roots are complex numbers. Right now? Roots are complex numbers. Getting that? Therefore.
Hello, sir.
So shortcut method is applicable for whether the roots are real numbers, complex numbers, doesn't matter. Yes, continue. Shreyas, continue. Continue.
Sir,
You are not audible.
Examples बघायला वर्क नाही करू शकत.
हे सगळं सांगणार, but you have to keep patience for that. I am understanding your question.
तुम्ही बोलला होता.
एक मिनिट ऐक मी काय म्हणतोय. I'll give you n number of examples where shortcut method is not applicable. But for that you have to keep patience. Time being, what we have to understand what is shortcut method and how it can be applied for the function e raised to ax. Okay. In due course of time, I am going to answer your question also. But for that you have to keep patience. Please. Right. D square minus 2d. I do remember. I know all your doubts, all your questions. So please keep some patience. I'll come to your doubts also. Okay, so d square minus 2d plus 2. So again, if you remember, if you try to find roots of this, we don't have real roots. We have complex roots. And if I am not wrong, the roots are like this. Please you cross check. I'm writing question mark. I know that they are the complex numbers. What exactly complex numbers are there? I think 2 is not there. 1 plus minus I might be. Please you check it. But complex numbers are there. So y of p equal to, again our aim is not to find the complementary function. Aim is to find the particular integral. and we know the method. Yes, what is to be done? D is to be replaced by A. A is equal to 2. This number, the coefficient of x. So 1 upon 4 minus 4 plus 2 e raised to 2x. That is e raised to 2x divided by 2. Hope you are getting this. Understood? Can I go to the next page?
Yes, sir.
Okay, so third. Now I am expecting answer of this question from you. Yes, try to solve this. Question number 3. D square plus 16y equal to e raised to okay, small change, minus sign, please make the small change. D square minus 16y equal to e raised to 4x. 1 upon d square minus 16 e raised to 4x. So d is to be replaced by 4. Yes, do it. So like this, 16 minus 16. So we are getting 0 in denominator. And if we keep 0 in denominator as it is, we'll get infinity. But we don't want this infinity as the answer. So first formula, whatever formula we have written before, first formula is not applicable. This is the conclusion. So something second formula should be there. Okay, so I'm leaving the derivation part to you. If you want, you can go through the derivation. Let me write the second formula. So formulas, right? 1 upon phi of d operated on e raised to x equal to 1 upon phi of a e raised to x, provided, now I am writing the condition, phi of a not equal to 0. Getting that is the first formula. Now what is the second formula? Now I am writing the second formula. Where phi of a equal to 0. Now tell me when the phi of a will become 0. It should be like this: d minus a and to be operated on e raised to x. Right now? So d minus a raised to, say, d minus a is repeated r times. So the formula is x raised to r divided by r factorial e raised to x. Or we can generalize the formula in this way also. 1 upon phi of d e raised to x. Again, we have phi of a equal to 0 in this case also. So it is अरे बापरे, विसरलो काय. एक मिनिट बघावं लागेल. बऱ्याच दिवसानंतर शिकवते. जरा एक मिनिट द्या, मला फॉर्म्युला बघून दे. आठवतोय पण थोडस एक्झॅक्ट डिफिकल्ट टू रिमेंबर. So x 1 upon phi of d, correct. X 1 upon derivative of phi, phi dash of d. This is dash is for the derivative and to be operated on e raised to x, where phi dash of d is derivative of phi of d with respect to d. If you want, you can mention it. Okay, what does it mean? It is like this. For example, let me take the previous example. 1 upon d square minus 16 e raised to 4x. So it becomes 1 upon 0 e raised to 4x, right now? We have seen it here. Okay, so we have to use second formula. How? X, right? And 1 upon derivative of d square minus 16. What is derivative of d square with respect to d? 2d. What is derivative of 16? 0. And to be operated on e raised to 4x. Now replace d by a. 4. So x 1 upon d equal to 4. 4 into 2, 8 and e raised to 4x. So x e raised to 4x divided by 8. This is the answer. Hope you are getting it. Hope you might have understood it. आ रहा है सबको समझ में? चलो और कुछ एग्जांपल देखते हैं ताकि वो समझ में आए हमें. Let me go through the next page. Right. Next. Okay. Let me change the page. It is like this. Third example. D square minus 25y equal to e raised to 5x. Yes, solve it. Let me make small change in the function. We are understanding one more concept also. Plus 3. E raised to 5x plus 3. So y of p equal to 1 upon d square minus 25. Right? E raised to 5x plus 3. So this plus 3, that will not make any problem for us. We have to consider the a, and what the a is? E raised to x. So coefficient of x only. And what is a here? So d is to be replaced by a, means 5 only. So keep the 3 as it is. That will not make any problem for us. So 25, d is 5 square, na? So 25. 25 minus 25, that will become 0. No change in this function. So what is conclusion? First formula fails. I do remember when I started teaching engineering mathematics 3 long back, around 7 to 8 years back. I have seen that student used to write first formula fails as example fails. So example will not fail, right? Na? I can fail, you can fail, right? Formula can fail, but example cannot fail. So don't write example fails, right? Formula fails. So better, right? First formula fails. So second formula. So what is second formula? X and then derivative. So derivative from here. So again derivative of d square 2d. Derivative of 25 0. E raised to 5x plus 3. Now you replace d by 5. So x by 10 e raised to 5x plus 3. Yes, clear. Any doubt in this example? Any doubt in this example? Yes, continue. Yes, any doubt? Okay, चलो आगे बढ़ते हैं. Let me add a few more formulas to the list. So, other exponential functions. Hey, what do you mean by exponential function? क्या होता है exponential function? What is the definition? अच्छा, मुझे ये बताओ. 5 raised to x exponential function है क्या? Is it the exponential function? 2 raised to minus x, is it the exponential function? 3 raised to 4x, is it the exponential function? Achha, can I consider constant number as an exponential function? All are exponential function. Timing you leave this. I'll tell you about the constant function afterwards, okay? But at least you understand these three functions, why they are exponential. What is the exponential function? Base is constant and power is function of x. Okay, so okay, let me consider like this. Y equal to a raised to x. Right, now let me take log on both sides. I'll do it here only. Log of y equal to x log a, isn't it? So say I want to find y from here. So what the y is? E raised to log a into x. Right? I have taken e on both sides, exponent on both sides. Right? So say I want to operate 1 upon phi of d on a raised to x. Getting na? So I'll write 1 upon phi of d to be operated on what the a raised to x is. A raised to x is this thing. Okay. E raised to log a x. And what we used to do in this formula? We replace d by coefficient of x, that is log a. Getting everyone na? So 1 upon phi of log a. And then e raised to log a into x. But what is log ax? यहाँ पे लिखा है हमने. कहाँ पे लिखा है? यहाँ पे y, और y क्या है? a raised to x. So 1 upon phi of log a raised to x. आ रहा है सबको समझ में? So operating 1 upon phi of d on a raised to x means replacing d by log a. इतना समझ में आ गया आपको? Have you understood this statement? Have you understood this statement? अरे कुछ तो बोलो यार. कुछ नहीं बोलोगे तो मुझे कैसे समझ में आएगा?
Yes, sir.
हाँ, understood ना? Right. Now let me continue. We'll develop formula for y equal to a raised to x. In the same way, let me develop the formula for a raised to minus 6. So y equal to a raised to minus 6. Let me take log on both sides. So log y equal to minus x log a. थोड़ा मैं ज्यादा लिखता हूँ इस बार. Okay, so take antilog. So e raised to minus x log a. But what the y is? यहाँ पे लिखा है हमने a raised to minus 6. So what is a raised to minus 6? E raised to minus of log a into x. So say I want to operate 1 upon phi of d on a raised to minus 6. That is operating 1 upon phi of d on e raised to minus log a x. But what is formula? What is shortcut method formula for exponential function? We have to replace d by coefficient of the x. In this case, minus log a. So phi of minus log a. But what this function is written here? A raised to minus 6. Getting everyone? Are you getting this? Okay. Now let me consider y as a constant. K constant. So say I want to operate 1 upon phi of d on k. So 1 upon phi of d operated on k into e raised to 0x. E raised to 0x is e raised to 0. E raised to 0 is 1. So now I have to replace d by, yes, d किससे replace कर रहा है हमें यहाँ पे? हाँ, कोई तो बताओ. Yes, कौस्तुभ, सरस, नहीं सरस नहीं, सरस मैकेनिकल है, सॉरी. तेजस, ये यार झुकले कैसे?
0.
हाँ, very good. Coefficient of the x, and which is the coefficient of x? 0. हाँ.
पण ते 0 केलं की 1/0 बनतं का?
नहीं, phi of 0 ना, isn't it? Array, suppose I have 1 upon d square plus 3 operated on some constant. So I'd replace d by 0 na. So how it will become 0? It will be 1 upon 3 into k. Yes or no?
Yes, sir.
Okay. Acha. So now we studied 5 formulas. Formula number 1, formula number 2. Then on previous page we studied one formula. This is the formula number 4. This is the formula number 5. Let me write all the 5 formulas together. Okay. And then we'll solve examples on those 5 formulas. Okay. So formulas. काय अवघड वाटायला लागले क्या? डिफिकल्ट लग रहा है क्या? 1 upon phi of d operated on e raised to x. So 1 upon phi of a e raised to x, provided phi of a is not equal to 0. Okay. Second, when phi of a is 0, what is to be done? So 1 upon phi of d operated on e raised to x. What do we have to do? Write x, then 1 upon phi dash of d e raised to x. Getting? Right? Now third formula, 1 upon phi of d operated on a raised to x. क्या करना है हमें यहाँ पे? 1 upon phi of replace d by log a, है ना? a raised to x. Simple. Fourth formula, 1 upon phi of d operated on a raised to minus 6. Yes, 1 upon phi of minus log a raised to minus x. लिखना है आपको, हाँ. Then fifth formula, 1 upon phi of d operated on k. K is a constant. So 1 upon phi of 0 and then k. Right. K is a constant. ठीक है. और एक फॉर्मूला हमने थोड़ी देर पहले लिखा था, 1 अपॉन डी माइनस ए रेस टू आर, ए रेस टू ए नहीं, ई रेस टू एक्स, ई है, हाँ, ई रेस टू एक्स. सो इट इज एक्स रेस टू आर डिवाइडेड बाय आर फैक्टोरियल, मे बी आस्क्ड इन द एमसीक्यू, ई रेस टू एक्स. 6 फॉर्मूले हमें करने हैं यहाँ से. इज इट क्लियर? हैव यू अंडरस्टूड इट? सबको समझ में आ रहा है? Everyone is getting this? चलो मैं क्वेश्चन पूछता हूँ so that I'll come to know whether you understood it or not, since you are not speaking anything and then it is difficult for me to decide the speed. आशुतोष, कुठे गेला आशुतोष? जेवायला गेला काय? आशुतोष पाटिल, अरे नाम में पाटिल है यार, इतना तो आशुतोष सारे नावात पाटिल है रे राजा, लक्षात ठेव की. आहेस की नाही?
आहे सर.
जेवण बिवण काय
नंतर करेल.
अच्छा नंतर आहे ना. ओके ओके गुड. अच्छा, हैव यू अंडरस्टूड द 6 फॉर्म्युलेज की काय झेपना? यस, समझ में आ रहा है या नहीं? आशुतोष काय तर बोल. दोनच गोष्टी होऊ शकतात ना. येस, आय एम अंडरस्टँडिंग इट. येस, आय हॅव नॉट अंडरस्टूड एनिथिंग. आशुतोष बोल ना.
यस सर, अंडरस्टूड.
Then I am going to ask you a question. Next question is for Ashutosh. Huh? Once I start, I'll ask you a question. Okay. Chirag. Chirag hai ki nahi? Chirag Sonone. Chirag, are you here? Acha, are you there? What I should ask? Acha, okay. Dhanasri.
Yes, sir.
Understood or not the 6 formulas? Yes or no? Acha, I'll ask same question once again. Let me solve few examples. Okay, chala example solve karo. At least remember the formulas. Keep them inside. Let me go through few examples. Okay. Yes. Right up. Find. Let me change the page. Right on. Find question pi, particular integral, right? 1. Again, let me start with few simple examples. Okay, like this. Yes, d square plus 5d plus 6y equal to e raised to say minus x. So y of p equal to 1 upon, उसमें कुछ difficult है नहीं, you don't have to integrate anywhere, e raised to minus x. What is to be done? D is to be replaced by Dhanasri. D is to be replaced by D is to be replaced by, अरे बताओ.
-1.
हाँ, okay. D is to be replaced by -1. So 1 upon D is -1. -1 square plus 5 into D plus 6. So e raised to -x. Let me simplify it here. So 1 upon 1 minus 5 plus 6. Hope everyone is getting this. So 1 upon 2 e raised to -x. 1 upon 2 e raised to -x. अरे इतना तो समझ में आ गया. फॉर्मूला नंबर 1, we have used formula number 1. Nothing difficult. Yes. Okay.
Yes, sir.
Great. चलो next. Right. D square minus 3y equal to e raised to root 3x. चलो सॉल्व करते हैं. Y of p equal to 1 upon d square minus 3 e raised to root 3x. अच्छा क्या करना है हमें? d is to be replaced by root 3. So 1 upon root 3 square minus 3. No change in the function. Okay, so 3 minus 3 होगा वो. Okay, so what is conclusion? First formula fails. First formula is not applicable. You can write like this. Alright, सबको समझ में? Everyone is getting this. Now what is to be done? I had to use the second formula. What is the second formula? X. Now question may be from where we are getting this x. For that you have to derive the formula. Okay, so use any reference book or Google it. Or derivation, you will get the derivation. Huh? If you want to understand how we are getting the formula number 2, you have to derive the formula. For that you can use any reference book. No any problem. Okay. So derivative of this term. Now while finding derivative, don't use u by v rule. Huh? You have to keep 1 as it is in the numerator, derivative of the denominator only, and that is to be written in denominator only, 2d, and then e raised to root 3x. Okay, now replace d by root 3. That's it. Okay, so x 1 upon 2 root 3 e raised to root 3x. That's it. Okay, x e raised to root 3x divided by 2 root 3. This is the answer. होप सबको समझ में आ रहा है? चलो आगे बढ़ते हैं. Let me increase the difficulty level. D square minus 6d plus 9y equal to e raised to 3x. चलो सॉल्व करते हैं इसको. Y of p equal to 1 upon d square minus 6d plus 9 equal to e raised to 3x. क्या करना है हमें? d is to be replaced by 3. चलो रिप्लेस करते हैं and then we will see what is happening. Can I change the page? करो अभी चेंज पेज कर देता हूं. ठीक है, रिटर्न एवरीथिंग. ज्यादा फास्ट नहीं हो रहा है ना? Are you able to write it?
Yes,
And again, it is not required to write all the steps. Huh? Once you understand, you can skip few steps. हाँ बताओ. Okay,
yes.
Let me change the page. Now I will replace d by 3. Huh? So it is like this. Y of change page. D square minus 60. Huh? So y of p equal to d square. So it was 3 square 9 minus 6d 18 plus 9 e raised to minus 3x. 3x or plus 3x? क्या है? Plus 3x or minus 3x? I think plus 3x.
Plus
3x.
Plus
Okay. So formula, or you mentioned first formula. Formula fails, right? First formula, so that there will be no any confusion. Okay, so we have to use the second formula. Okay, so what is second formula? X. and then derivative of denominator, d square minus 6d. So 2d d square minus 6d, so minus 6, and derivative of constant is 0, and then e raised to 3x. अब क्या करना पड़ेगा? Again we have to use the first formula, हाँ? Using first formula. So what is first formula? Now understand, there should not be any confusion. What is first formula? First formula क्या बोल रहा है हमें? D को A से replace करो, that's it. What is second formula? Second formula क्या बता रहा है हमें? 1 upon x लिखो और डेरिवेटिव फाइंड करो, बाकी छोड़ दो सब.
थर्ड
हाँ हाँ
थर्ड अजून एकदा डेरिव्हेटिव्ह काढायचा का?
हाँ, absolutely, no doubt.
सर्कल फंक्शन चेंज होतं ना आपलं मग
हाँ होते ना, काय प्रॉब्लेम नाही ना.
x into the power 3x होतं
नहीं,
ना.
एक मिनट, स्टेप बाय स्टेप. हाँ, so here we used first formula up to this step. Got it? First formula. ठीक है? Then we use the second formula. यहाँ तक हमने second formula use किया. Second formula. Right? Again I am using the first formula. आ रहा है ना सबको समझ में? Why I am saying I am using the first formula? Since I am replacing d by 3, therefore. Okay? Again I got 6 minus 6. 0. So what is conclusion? First formula fails, isn't it? Now what I have to use? I have to use the second formula. Now what is second formula? Already one x is there, यहाँ पे, हाँ, और एक x लिखना है मुझे. So x into x is x square. Then derivative of denominator 1 upon 2. Now no any d term is remaining, and therefore this is the answer. अरे काय झेपते की नहीं? किंवा you leave this first and second formula. You just remember that whenever we get 0, we have to write x and derivative of denominator. First and second हे सगळं सोडून दे, क्या प्रॉब्लम है? हाँ, ये जो हम लिख रहे हैं ना, फर्स्ट यूज करो, सेकंड यूज करो, सब छोड़ दो. इतना याद रखो, once we get 0, x and derivative, that's it. Getting
Hello, sir?
everyone? हाँ हाँ, yes.
आपण जेव्हा सेकंड टाइम सेकंड फॉर्म्युला वापरला ना, त्यात आपलं फंक्शन हे झालं होतं ना, x into e to the power 3x झालेलं ना.
हाँ हाँ हाँ,
e to the power 3x नाही, म्हणजे एक एक्सपोनेन्शियल फंक्शन आहे ज्याला आपण शॉर्टकट मेथड वापरतो, पण आपल्याकडे सेकंड न्यू फंक्शन आहे x into e to the power 3x. सो आपण डायरेक्टली त्याला सेकंड फॉर्म्युला कसं काय वापरला?
हाँ हाँ हाँ, ओके ओके. See, हे x, this operator is there ना? हा ऑपरेटर है कि नहीं? Why I am saying it as?
ओके ओके ओके.
हाँ, just 1 minute. This might be doubt for everyone. I think this is निकुंभ ना? कौन बोल रहा था?
हो सर, मी बोललो.
अरे कड़ा आवाज बघ. हाँ, so this 1 upon 2d minus 6 is operator. Why I am saying is that operator, since d is there and d is the d by dx derivative, right na? So this is operator, and to be operated on exponential function only, not on the x. X is like a constant, not a constant, but like a constant when we are using the formula. Therefore, okay, have you understood this?
ओके सर.
Do you got the answer?
e to the power. ओके सर, आला.
Okay, let me continue. This is the answer. That's it. Okay. Example number 3, 4, I think. Okay, let me continue with few more examples. Okay, it is like this. Okay. Right. D square plus D plus 1y equal to 17 alpha. Whether it is 17 or 17 alpha, I don't think difference is there. So y of p equal to d square plus d plus 1 operated on 17 alpha. What is 17 alpha? Right inside. What is 17 alpha? Constant. And what is formula for constant? We have replaced d by what? 0. 1 upon 0 plus 1 into 17 alpha. So what the answer is? 17 alpha. That's it. Getting everyone? How to use the formula for constant? Okay, let me continue. Can I change the page now? आ रहा है सबको समझ में? चलो पेज चेंज करते हैं. For example number 5, d square, like example is like this, d square plus 9y equal to 3 raised to x plus 3 raised to minus x. So y of p equal to 1 upon d square plus 9 to be operated on 3 raised to x plus 3 raised to minus x. So linearity property आप समझते हैं ना? So I am using the linearity property of the operator. Operator is linear, means I can operate 1 upon d square plus 9 on 3 raised to x and 3 raised to minus x separately, and then I can add the answer. Okay, so what we have to do in the first case, let me write the formula using 1 upon phi of d operated on a raised to x. क्या होता है ये? 1 upon phi of what? Log a, right ना? So here in the first case we have to replace d by log of a, that is log of 3, and in second case here we have to replace d by minus of log 3. Why minus? Since e raised to minus 3x is there, therefore. So 1 upon from here I am writing the answer. So 1 upon log 3 square plus 9 and 3 raised to x plus 1 upon minus log 3 whole square plus 9 and then 3 raised to minus 6. You can keep answer as it is, or you can write one more step. Log 3 square plus 9 3 raised to x plus this minus sign will cancel. So log 3 square plus 9 3 raised to minus 6. You can keep answer as it is, or if you want you can simplify it. Coefficient is same. आ रहा है सबको समझ में? Understood? Now have you understood these 5 formulas? Yes or no?
Yes, sir.
Okay, चलो next पढ़ते हैं. d minus 1 raised to 5y equal to, चलो थोड़ा सा चेंज करता हूं, d minus 3, okay, e raised to 3x, d minus 3 raised to 5y. So using, I'll mention the formula, 1 upon, hope you remember, d minus a raised to r e raised to x. What is the answer? X raised to r divided by r factorial e raised to x. So 1 upon y of p, 1 upon d minus 3 raised to 5 e raised to 3x. So x raised to r क्या है यहाँ पे? 5 है. X raised to 5 divided by 5 factorial. Here r equal to 5, a equal to 3 into e raised to 3x. ये हो गया आंसर आपका. हो गया, that's it. Are you getting all these examples? सबको समझ में आ रहा है?
Yes, sir.
Okay, great. एक last example and then we'll stop. 7th example. Can I change the page?
Yes, sir.
Okay. So, क्या example number of the last? It was 6th example, 7th example. Question set is uploaded on the Google Classroom. Please go through the examples on the shortcut method. Page number 9 or 10 is there. You solve the remaining examples, okay? As well as one question is given, right? You have to write applications of the differential equation. It will be better if you are able to write applications of differential equation in the civil engineering. Any differential equation, that is homework. You have to complete it by Monday. You can use reference book or Google it, no problem. Okay, so it is like this. d square plus 3d plus 2y equal to, right, 2 raised to 3x minus of log 2, okay, minus of log 2. Yes, sir. Y of p equal to 1 upon d square plus 3d plus 2 to be operated on 2 raised to 3x minus log 2. So 1 upon d is faster, and then we'll stop. 2 raised to 3x minus 1 upon d square using the linearity log 2. Okay. Now, since I think you know all these things, 2 raised to 3x, that may be written as 2 raised to 3 whole raised to x. Okay. That is 2 raised to 3 is 8, 8 raised to x. So we have to replace d by what? Log of what? Log of 8. Or you can do it in this way also, huh? Log of 2 raised to 3. Both are same only, huh? Understand the mathematics behind it. So you should know the logarithmic formulas very well. So whether you write log 8 or 3 log 2, both have same meaning. Both are equal. Okay. I am doing this. I am replacing d by log 8 in this case. What to do about the second case? यहाँ पे क्या करना है हमें? D is to be replaced by what? Anyone? D किससे replace करना है? 2 raised to x से करना है? Let me give you the example. 2 raised to x है या log of 2 है? किससे replace करना है हमें? D यहाँ पे for the log 2. अरे कोई तो बताओ?
Log of 2 constant.
Very good, very good. Okay, so since please fast, log 2 equal to constant है. Log 2 constant है. Constant कैसे पता चला? Free from. What is constant? Free from x or variable. Better to write variable, but everywhere we are using x, therefore I am saying that free from the x. Free from variable means constant. Okay, fast. इसको complete करते हैं. Y of p 1 upon d is to be replaced by log 8. Log 8 square plus 3 log 8 plus 2 into 2 raised to 3x minus d is to be replaced by 0. 0 plus 2 log 2. That's it. So answer is this term as it is minus log 2 divided by 2. ये हो गया आंसर आपका. That's it. You can leave, no problem. Attendance is already taken through ERP module, so no need to take the attendance. We'll continue tomorrow. If any change is required, let me know. If you are going fast, slow, whatever it is, please convey it to me so that I can make the required changes. You can leave, there is no any problem. आपको यदि जाना है तो जा सकते हैं आप. शायद ब्रेक है आपको अभी खाने का, right ना? So you can leave.
Okay,
no
sir.
any
Thank you,
problem.
sir.
Okay, thank you.